YouTube channel, and we are discussing the video lecture series on basic electrical engineering. In the previous video, we have started one chapter, that is AC circuits, and we have covered the most important topic of that chapter, and that was the generation of alternating voltage. How voltage is generated and how it is in sinusoidal waveform. Also, we have proved the equation of generated EMF. So that generated EMF will be always in sinusoidal waveform. So now let's discuss some important definition related to that sinusoidal waveform. So let's consider one waveform you can see here. So this waveform is known as sinusoidal waveform. So for any instant, if we consider our first definition, that is cycle. So what is the definition of cycle? So cycle is the set of all the values, that is positive, negative and zero of any alternating quantity. Cycle is defined as the all zero, positive as well as negative values of any alternating quantity. So here you can see that there is a positive value, there is a negative value and zero value. And you can see in the first waveform, that is, it started from 0 and it ended at 360 degree. So this 0 to 360 rotation of a coil will produce one complete set of EMF, and that is known as the cycle. Now let's move towards the next definition. And next definition is instantaneous value. What do you mean by instantaneous value? So you can see in this waveform, there are so many instant of time available in this one complete cycle. So if one wants to find the value of generated EMF or a current at any instant, at any angle, at any time, at any moment, what is the EMF at 17 degree, for example? What is the EMF at 90 degree? What is the EMF at 180 degree? So the instantaneous value is defined as the value of an alternating quantity at any instant of time. For example, you can see that we have considered two times in this waveform. For example, let's say there is a t1 time. So you can see in this waveform at t1 time there is a value of EMF or the voltage as V1. So that V1 is known as the value of the instantaneous EMF at time t1. Also you can see that there is a time t2, and you can see that at time t2 there is an instant value, that is V2. So basically instantaneous value of any alternating quantity is the value of that quantity at any instant of time. It may be a voltage, current, power or anything. Let's move towards the next definition. And next definition is the maximum value, amplitude, or you can say the peak value. So what do you mean by the maximum value? You can see these two waveforms. Waveform starts from 0. It reaches to its maximum value. And then it starts decreasing and completes one half cycle. Then again, the waveform starts increasing in the reverse direction, in the negative direction. And again it reaches to its maximum value. And it completes and it decreases and completes one cycle. So you can see that there are two peak points in one complete cycle. And this peak value, this maximum value is known as the amplitude. So amplitude, maximum value or the peak is the same, that is the maximum highest value that our quantity has reached in any cycle. That maximum value can be either in positive or in negative. You can see that there are maximum values in positive and as well as in negative. Let's move towards the next definition. And next definition is angular frequency. So what do you mean by angular frequency? So angular frequency is the frequency expressed in radians per second. Radians is the angular displacement and seconds are the time. So angular frequency is the how much of angles that coil has rotated per unit time. So basically angular frequency is the angular rotation per unit time. Okay, so basically angular frequency is denoted by the omega. And we have studied in a previous video that omega is equals to 2 pi f. You can say that omega is equals to 2 pi f, where 2 pi is the one complete rotation 360 degree and f is the frequency. So omega is equals to 2 pi f. So this is known as the angular frequency. Angular frequency is very important term in related to this alternating quantities. Now let's see the next definition, and next definition is frequency. Once we have decided our angular frequency, then we can decide the value of frequency. Because frequency is nothing but the number of cycles passing through 1 second in any alternating cycle. Or you can say number of cycles that generated in 1 second is known as the frequency. Frequency is denoted by F and its units is in hertz. For example, in India, we heard many times that our instrument and every application has frequency 50 hertz. So what does that mean? What do you mean by 50 hertz frequency? So that means in 1 second, 50 cycles has been passed. So that means we have 50 hertz. In different countries, frequency might be different. So basically, frequency is the number of cycles passed in 1 second. Now let's move towards the next definition. And next definition is time period. So frequency and time period are just correlated terms. Time period is nothing but it is the time required by an alternating quantity to complete one cycle. Means from 0 to maximum to 180 degree, you can see that 180 degree from 180 to 270 and 270 to 360. So that is one cycle. In that frequency definition, number of cycles per second, and here the definition is it is the time required to complete one cycle. So basically these two terms are reciprocal to each other. So time period is inversely proportional to the frequency. So T is equals to 1 upon F. And the unit of time period will be in seconds. And in India, if our frequency are 50, so 1 upon 50 will give you 0.02 second. So in 0.02 second, you can say that one cycle has passed. So that was the time period. Now let's move towards the next definition. And the next and important definition is phase. What do you mean by phase? So the phase term means the phase of an alternating quantity is defined as the fraction of that time period that has elapsed since our quantity has last passed through 0 point of reference. So you can say in this figure, our first waveform is starting from 0 and it completes at 360 degree. But you can see that at some angle phi, or you can say that at some time t1. So what is the phase of that quantity? That is phi. Because quantity has started from 0 and at that point they have just rotated phi degree. So the point at which we are measuring quantity and the phase of that quantity is defined as the time period that has elapsed since 0 point of reference has passed. So you can say that the phase of particular at that instant t1, or you can say that the phase of that voltage v1 is 5 degree. You can say that the phase at this maximum value Vm is 90 degree, because from 0 degree it has rotated by 90 degree, the time has elapsed by 90 degree. So you can say that maximum value is having phase of 90 degree. So that was the definition of phase. So you can find phase of at any point of any alternating quantity. Phase is important term, but the next definition that is phase difference, is very important because we will often measure the difference between angle of two alternating quantities. So how we can define the phase difference? So the phase difference may be defined as the difference between the phases of the alternating quantities, or you can say that the difference between phase angle of two alternating quantities. You can see in these two waveforms. First waveform has started through 0 and completed at 360 degree. And another waveform is not started at 0 degree, but another waveform has started at 90 degree. So it will complete after 90 degree of 360, that is 360 plus 90. So the phase difference is there in these two waveforms. So what is the value of that phase difference? You can easily check that first waveform has started through 0, second waveform has started through 90 degree. So you can say that there is a phase difference of 90 degree between these two waveforms. In next few lectures, we will discuss about phase difference, how some quantities are just lagging from another quantity, leading from another quantity, and how two quantities are in phase. That we will discuss in next few lectures. But here the phase difference means two quantity has not started through 0, same point, not reaching the maximum value at same point, and not completing the cycle at the same point. So we can say that there is a phase difference, and in this figure you can say that there is a 90 degree phase difference between these two waveforms. So that was the phase difference. So this was all about the definition related to AC circuit. We will discuss some circuits and average value, RMS value related to that circuit. Thanks for watching this video. Stay tuned.